Okay. For number one, our approach to each of these problems relies on us being able to identify what we're dealing with in each case. So in the first case, calcium hydroxide is a strong base. Second case, potassium fluoride, we have a salt. So I'm going to be looking for hydrolysis. And the third case, formic acid, which is HCOOH, or on your chart, it's probably HCHO2 or something like that. That's going to be a weak acid approach. So for the strong base, calcium hydroxide is CaOH2. So when that dissociates, it's going to give us two hydroxides for every one we started with. So if the calcium hydroxide is 0.002, we're going to multiply by a mole ratio to give us the hydroxide concentration of 0.004. I'm going to take the negative log of that, and that'll give me POH is 2.40, and then subtract from 14 gives me 11.60. For the second problem, KF is a salt that dissolves in water. And so when it does, it's going to break into K and F. I want to consider which ion undergoes hydrolysis. K will not. K never does anything. F minus behaves as a weak base. So I need to now do a weak base problem with F minus. So I'm going to write the reaction with water. It's going to steal an H from the water and produce hydroxide. 0.6 minus X is still 0.6 because our assumption is valid, always. So now I'm going to need to do a KB problem. The problem is, or the issue is, you have to deal with the KAs and KBs that are given on the bottom of this page. If we go down here, notice there's no KB for F minus. There is, however, a Ka for HF, so we are going to be able to calculate the KB we need. So 6.6 times 10 to the negative fourth. So Ka times Kb equals 1 times 10 to the negative 14th. Ka is 6.6 times 10 to the negative, I think it was fourth. So that times Kb equals 1 times 10 to the negative 14th. Kb is 1.5, excuse me, 1.5 times 10 to the negative 11th equals x squared over 0.6. Times 0.6, square root answer. We get x, which is our hydroxide concentration in this problem, to be 3.02 times 10 to the negative sixth. POH, pH. POH is 5.52. And then pH is 8.48. For the formic acid problem, we have a weak acid problem, and our K is conveniently given. If I want to shortcut the table, I can, because I get to decide what I get to do. The Ka for formic acid is at the bottom here. 1.8 times 10 to the negative fourth. And X is the hydrogen ion concentration in this problem because it's a weak acid problem. 0.016. Negative log of that gives me the pH.